Good morning, friends. Welcome to GoOnlineTrainings.com. So, already we are aware that with the help of OLTP systems, and we should be able to get the data into the OLAP systems. Okay, you have OLTP databases. The OLTP system could be SAP system or Oracle or DB2, Java, .NET. So we have to perform ETL operations with the help of SSIS or Informatica, Data Stage, Ab initio. Any tool you should be able to use, and you have to derive a OLAP, nothing but a data warehousing system. The first principle is that how can we create a OLTP system, or how the database modeling is done for the OLTP systems. Normally, people are going to be using ERD modeling, right? Entity relationship diagram is used to create the any OLTP database. Okay, so ERD modeling is introduced by Dr. Peter Chen in 1970s. But when we're talking about OLAP system or we're talking about data warehousing, how the data warehousing can be modeled. So there is a designing principle called dimension modeling that we're going to be understanding. Okay. So this dimension modeling is given by Dr. Kimball in 1990s. So to prepare any kind of a system, you have to have the design. Without the design, we will not be able to implement anything over there. So to design the data warehouse, we'll be using a system called dimension modeling. Let us understand what is a dimension modeling, or let us understand how can we convert OLTP to OLAP. So let me tell you the agenda today. The agenda is that designing principles of data warehousing and introduction to dimension modeling, and what is a fact or a measure, and what is a dimension, and the dimension hierarchies and types of dimensions and facts, and introduction to schemas. Okay, and we'll have star schema, snowflake schema, double star schema, or galaxy schema, something like that. Okay, let me tell you why is that we are learning data warehousing. So as we discussed already, you have OLTP systems, and later you have staging and the data warehousing. Once the data warehouse is built, then based on the data warehouse, we will be implementing a cube on this. Clear? So if you wanted to work with SSAS, and definitely you have to have the data warehousing to be ready. And I'm not drawing the staging in between. So make sure that so from the OLTP data with the help of ETL, we create a data warehouse. Once a data warehouse is created, now the data will be going to the SSAS system, and where you will be able to create a cube and perform multi-dimensional analysis. So based on the cube, you will be able to create lot of reports. Okay. So you have SSRS is there. So people are going to be using SSRS to create a reports. Either they will be able to get the data from cube and they write lot of MDX queries, or you should be able to get the data, do like this, or you can also get the data from the OLTP applications and you should be able to create lot of reports. Okay. Instead of SSRS, you can also go in for Power BI. People can get the data from SSAS. So this is where we have to use MDX queries, and to get the data from the data warehousing, we will be writing normal queries. And if you get the data from other than the data warehouse, you may have data in SQL Server, Oracle. So here also we have to write normal queries and get the data and create a lot of reports and give it to the end user. Clear? So if you wanted to create a data warehouse, first you have to understand how does OLTP designed and what is a OLTP all about. Clear? So to design the OLTP databases, we use a concept called ERD modeling. So I wanted to construct a house. So if you wanted to construct a house, definitely we have to get a design done, and based on the design, you're going to be creating or constructing in house. I wanted to build a metro train. Can I use a metro station or metro train project without a diagram or a design? It is completely impossible. So definitely you have to have the design work to be done properly. Based on the design, you have to create a data warehouse or the OLTP databases or data warehouse databases. So here we're going to be using ERD modeling. Here we're going to be using a concept called dimension modeling. So these are the designing concepts. Okay. Now, OLTP is also a database. Data warehouse is also database. Database means we know that it will have a tables. Okay. So here you will have lot of tables, and here also you have lot of tables. Now, what are the types of the tables you will be able to find in OLTP databases, and what are the types of the tables you will be able to find out in the data warehouse? Basically, you have two types of tables in OLTP systems, and in the data warehouse also you have two types of tables. Okay. Now, I wanted to tell you what are the types of the tables we have in the OLTP databases. So there is a table type called master tables, and there are one more table called transactional tables. So whenever you open any OLTP databases, they'll have two types of tables over there. One is called master table. The second one is called transactional tables. Okay. So what is a master table and how can we understand this is a master table or not? Let us understand. So master tables are will have few properties that you need to understand. Okay. Let us, I am talking about Amazon.com. So Amazon.com will have OLTP database. OLTP database means whenever you buying any item, your data, your transactional data will get recorded in one more database. Yesterday we were talking about OLTP data means fresh data, read and write data, live data, so normalized data. A lot of points we were discussing about, right? So OLTP data means that the customers are directly connected to this. Whenever you buy any product, so automatically the data will be going to the OLTP database. So, okay, we have a Amazon.com in our example. I'm trying to give you couple of tables of OLTP. For example, so when you open a site, you should be able to see a table called product table. So people will be calling as master table. So OLTP will have two types of a tables. I told you one is a master table. The second one is called transactional table. So product master is a master table. Okay, and I'll be giving you one more table. Whenever you register with the Amazon.com, you will be able to get one more table called customer table. So the first question is that how can we define this is a master table and this is a transactional table in the OLTP? Master tables will have more of primary keys. You have a lot of primary keys in the master tables, and master tables will have lot of string data or character var data, and master tables will have less data compared to we're talking about transactional tables. These are the three parameters you have to understand. Clear? So OLTP database will have master tables and transactional tables. Master tables will have primary keys. For example, I take some couple of columns here: product ID and name of the product and the price of the product, and you may have some kind of a description about the product, and you may have a quantity on your hand, something like this. Okay, so how many products you have as of now? So this is the some of the columns in this table, and here the product ID would be the primary key. Now whenever you register with the Amazon.com, you'll have a customer ID and name of the customer and the address of the customer, and we have a city in which you are available, and pin code and your phone number, something like this will get taken from you, and email ID and lot of other data will get inserted. So customer ID is the primary key here. So this is, you will have or more of string data, and somewhere you may be finding some kind of a numerical data, but more of string data will be there in the master tables. So I have taken product master, customer master, or you may have a table called categories also. For example, whenever you buy a product, you may have categories table. I am not giving, so let us simplify this. So after registering with the site, you wanted to buy some, items from the Amazon.com. There is a table called sales table will be there. So sales table will be a transactional table. In the transactional tables, the first property is that it will have more of foreign keys and more of numerical data will be there. And here you have large amount of data will be there. Okay, so these are the few properties that you have to understand. So whenever you go to OLTP database, you have two types of tables, master and transactional table. So I'm talking about sales data. Sales means I want to understand what is the product and who's the customer, and date of sales when it is sold, and what is the sales amount he paid, and what is the GST amount collected from him, and how many quantity sold or purchased. Okay, purchase quantity or quantity sold. And we can have date of delivery. Okay, date of delivery or expected date of delivery. One is that the product uh, uh, will get be, expected to be delivered to the customer. So now when we're talking about here the sales table, this is what is the foreign key, because who what is the product which is being sold out, and who is the customer is being planning to buy, and when is that he made the payment, and sales amount how much is that is paid. Lot of things, GST, quantity sold. So you have more of numerical data. For example, I may have a customer here. So I have a product called one. Let us say I have a Lux soap and the price is 35 rupees. Description, some ABC description here. I have some 2000 products currently in the status. So I have a second what is called pens, and the pen is that this one. There is some description about the pens. I'm not writing. So I have currently 3000 pens. Like that, I have some data there, right? So I have customer ID one, say John, and some address is there in Bangalore. So some address, the city is I'm talking about Bangalore, and pin code is that 56001, and phone number some dot dot dot, email ID some dot dot dot. Everything will get captured there. And I have a one more customer called 101, say Ravi, from some address. He's staying in Hyderabad, and some pin code number let us have, and some data let us forget about this data. All this data will get registered. Okay, now once you get registered, the next one is that people are going to be buying lot of products. So the customer number, or say product number one and purchased by customer number 102, that is Ravi. Date of sales is happened, say let us say May 10th, okay, 2017. And what is the amount, sales amount we're talking about? What is the amount they have paid? Let us say some 1000 rupees, GST 120 rupees they paid, and they have purchased say 12 products, something like this. And expected date of delivery would be so May 10th, and it may be May 15th. Okay, so that is what is that they wanted to have it. So this is the data you will be having, something like. Now, if you take this data, you should be able to find out more of numerical data here. Okay. And here you will be able to find out more of string data. And now the first question you have to be understanding that always master tables are having less data. When you go to Amazon.com, there is a lot of products are going to display. Now, today also you will have same number of products, and tomorrow also when you open, you will be having some 2% products got extra, or some of the products may not be available there. They may delete something or they may include something, but not much more products will get change every day. So you may have 1% or 2% change. Now let us talk about the customer. Maximum, customers are already registered with Amazon.com because it is number one site. The maximum customers are already been added. So when you open tomorrow the site, you may be having very little data to the coming to the customer master table. So when we're talking about product master table, customers master tables, you will have initially a lot of inserts, but later the data will not going to be inserting. Large amount of data will not be there because you have only that much of a customers. Every day you may have 1%, 2%, 3%, 5% changes will be there, but not more than that. So master tables will have less data insertions once the data is inserted into the master tables. Now, when we're talking about transactional tables, you think you have 1 million customers and you think you have a 1 million data, and when you see the sales, now tell me, what are the data? What is the data size you will be getting into the sales table regularly? Is it only 5%? No, it is not 5%. Every day you may get 1 million extra data or 10 million extra data will get populated to the transactional table. The property of the transactional table is that large amount of data will get inserted because morning 9 to evening midnight 12 o'clock, people are keep on buying, keep on canceling it, or they wanted to exchange the products, or they wanted to do a lot of things. So the sales table is going to be occupying large amount of space. For example, my OLTP database size is, let us talk about it, is having some 500 GB. That is the space allocated for this database. Now at least 10%, okay, at least you may have a 10%, or you may have a 10 GB of data will be here. You may have some 20 GB of data somewhere here, or 10 GB data will be there, a 20 GB of data will be there. So you may have large amount of data. You can say that you may get every month, or every uh, quarter you may get 100 GB of data. You may have other tables also, I did not include them. So if you compare with the sizes also, you may have 10 GB of the table, or you may have 5 GB of the table. When you compare the transactional data, it is 100 GB of the data. You may be having 13 million data, 14 million data, 15 million data, 20 million data per month. You're getting it to this table. So when you compare the sizes also, the master tables are having little data, less data compared to transactional tables, and you have more and more string data, and here you'll have more and more numerical data. You have a primary keys here, you have a foreign keys here. That is what is the important point you have to understand. So master tables, you will have a customer table. Because of that reason only, people will say customer master. When you say customer master, you have to understand that which is a master table. You will have more of string data and less data, and you'll have primary keys in this. And we're talking about product master. So that is how the master name will be used in the OLTP databases. Now the database name could be here Amazon database. That's clear. So this is a OLTP database. OLTP database is connected to the users directly. That means whenever you connect to Amazon.com site, you are directly connected to Amazon OLTP database only. So you may register if you're the first time user, or if you're existing user, you may browsing the product. If you want to buy something, you can just click on and order. So that is how the things would happening. A simple database structure will be like this. Clear? So when we're talking about a data warehouse, now how do we get the data warehouse created? The data warehouse is also a database, but here we're talking about large amount of database will be created. The database name could be Amazon DW. Okay, this is also database only. And here, if you have the size, you say, let us say it is 500 GB. Now you will not be able to have a GBs of data. You may be, getting every month if you're getting 100 GB of data, or every annum if you're getting 500 GB of data. If you wanted to capture 10, 20 years of the data, definitely you need to have the data sizes in terabytes of the space to be allocated for the data warehousing databases. or wherever you have data warehouse databases, a special a server will be taken. So inside the server, you have large amount of hardware has to be there. Plus, you have to create a data warehouse database. Now, I have to create all the master tables here will be called as a dimensional tables, okay, and all the transactional tables are called as a fact tables, okay. So data warehouse will have two types of tables. One type of table is called dimensional table, one more type of the table is called fact table. So the customer table will become dimension customer. The naming convention also will change, and here we will be having dim product. So there we have a product table, and we'll be having a dim product table, and the sales table will become a fact sales table, like that. This is very simple designing, but if you see, is this the way the people are going to be designing the data warehouse? The answer is no. So this is only for understanding. When you see a OLTP database, roughly, or a layman understanding, how can we create a data warehouse means, you can simply tell them that take all the master tables, convert them into dimensional tables, and take all the transactional tables and convert them into fact tables. So fact tables is nothing but you have more numerical data, more foreign keys are available, and dimension tables will have more string data, more primary keys are available, and dimension tables and fact tables, both of them are connected with the primary keys and foreign keys. Here also we are able to connect these two tables and primary keys, foreign keys. This is how the people can say that what is the data warehouse is going to be containing, which is purely dimensional table. Dimensional table means I'm talking about master tables in the OLTP databases. So this is what you have to be clear enough to understand. Now, so if you give me a OLTP database, I can directly say that whenever you have a master table, product table, course table, for example, I'm talking about a college or I'm talking about an institution like Go Online Training. So we have a course table, we have a students inquiry table. All these tables are called master tables because once we published a 20 courses or 30 courses, and now the data in the course master will not get updated or inserted heavily, because once in a moon you may introduce one course, and the students data also we don't get much more inquiries here. So even though you get one or two inquiries, but we will have a lot of registrations, or what is that, the people are going to be joining. So admissions you call, or registrations you can call. So admission table, registration table will be the fact table for us. So whenever you make the payment, so who is that, who is the person who's going to be joining with a given course, student ID, course ID, what is the amount he has paid, lot of things. So that is we can say admission table, or we can say registration table, something like that. So upon payments table, you can have the table payments or registration admission table is called as a fact table, or known as a transactional table, something like that. Or you may have a sales table or orders table in case of we talking about Amazon example. Clear? So master tables converted as dimension tables and transactional tables are converted as fact tables. This is a simple way of understanding OLTP design to OLAP. OLAP means I'm talking about data warehousing, or designing. Now, let us understand dimension modeling. There is a different approach given by Dr. Kimball to create a data warehousing. So when you have complex data warehouse to be designed, it is not that you should be using the simple approach, convert all the that master tables into dimensional tables, not something like that. We have to use a proper approach to create this. So developed by Dr. Kimball, it's a data warehousing designing concept. It's process to convert all OLTP data into OLAP data. So OLAP data means I'm talking about all the master tables and transactional data into dimension tables and fact table data in the form of dimension tables and fact tables, and maintain the relationships between them with the help of a primary key and foreign key. Dimension modeling is heart of the data warehouse. Okay. So yesterday we had seen the gurus of data warehouse. We know that Kimball is one of the inventor of the data warehouse. We have Dr. Inman. He's also one more inventor of the data warehouse. So complete the industry, IT industry is following 60 to 70% of the IT industry is following a Kimball methodology. So Kimball is the guy who's going to be giving a dimension modeling concept. And Kimball says that Inman says that however you're designing OLTP, and the same way you should be able to design your data warehouse. That means OLTP databases will be designed with the help of ERD modeling. ERD modeling means you will have more of normalized data. So what is a normalization? We'll discuss later. So ERD modeling by default, which is going to be using normalized tables. Okay, you will be understanding normalization and everything. And when we using Inman approach, this is one of the important questions people would ask you in the interviews. Are you following a Inman methodology to create a data warehouse, or are you following Dr. Kimball methodology to create a data warehouse? So I'm talking about Inman methodology. According to the Inman, this is that. So you take the OLTP database with the help of ERD modeling, you derive it, and here also, when you're creating a data warehouse also, you use the ERD modeling only. You don't use dimension modeling and all. Okay. So in one approach is that data warehouse, if you wanted to create according to this guy, you have to use ERD modeling. ERD modeling is automatically uses normalization. So data warehouse will have more of normalized tables when we're talking about Inman approach. This is where lot of people got issues, and when you have a normalization concept, the data warehousing will become slow. Okay, so later we got Kimball in 1990s. Kimball says so. ERD modeling is very good. Normalization is very good for the OLTP thing, but normalization is not good for the or data warehousing. And Kimball says, I wanted to give you one more designing principle, that is what is called dimension modeling. And dimension modeling is going to be giving you denormalized architecture. Okay, so denormalized architecture where you will have more readability and faster readability will be there. So that is what is the bigger change from Inman to Kimball. So 70 to 80% of the companies, or you can take 60 to 70% of the companies, they're using dimension tables and fact tables. If somebody is saying I'm using a dimension table and fact table, that means indirectly they're following Kimball methodology to create a data warehouse. If somebody is saying I have a master table, I have a normalized concept into my data warehouse, then you can see that they're following completely Inman methodology. Even SSAS recommends, dimension modeling. So SSAS, Microsoft recommends it is completely a Kimball methodology. Kimball means I'm talking about dimension modeling and I'm talking about denormalized architecture. Clear? So this is what is the one more thing you have to understand when we're talking about dimension modeling. What is a dimension modeling? Let me explain in detail. Clear? So hope you're able to understand the different approaches of Enmon and the Kimball. Both of them are saying you can create a data warehouse. But Inman methodology is use ERD modeling with OLTP as well as the data warehouse. In both cases, you can use ERD modeling only. But now Kimball only says for the OLTP, you use ERD modeling. ERD modeling indirectly uses normalization concept. Normalization we'll discuss. And a data warehouse, if you wanted to create, use dimension modeling. When you use dimension modeling, automatically we use denormalized concept. And this is the approach given by Dr. Kimball. Now, let me give you a simple example of how can we uh, derive a dimension model. Okay, let me give you a simple example. I'm the CEO of the company, and I told today to all my shareholders, I'm the CEO, I'm announcing my profits today. I told everybody that I have got 1,000 crore profit. Okay. So this is the announcement I made to the public. When I say I got 1,000 crore profit in my business, you think about I am running Amazon.com, the CEO of the Amazon.com or CEO of, you can say, a Hindustan Unilever company or any company. So they have announced the result said I got 1,000 crore profit. When you see the 1,000 crore profit, so the immediately you should be able to measure the company. Okay, so the measurement is 1,000 here. So this is what is called as a measure. So measure is called as a fact also. What is the fact? Fact is that you got 1,000 crore profit. Okay, or this is also called as a metric. People will say metrics also. So, so by seeing the 1,000 crore, you should be able to measure the company. This is also called as a fact. The fact that we got 1,000 crore profit. The metrics is that it is saying clearly the company got 1,000 crore profit. So, or they may say that, sorry to say that I got 1,000 crore loss. Okay. So when you say loss, what is that you can measure? You can measure the company saying that the company is going in the reverse direction. It is not at all getting any profits now. It is useless to invest in my shares in this company. So you can have a minus value or the plus value. Still you should be able to understand that the company is doing good or doing bad. So measure means a numerical value. If somebody said what is a measure? If somebody says, so measure means numerical value. This is what a Kimball sir says. Okay, so numerical value. Now the second question is that can we take all numerical numbers, or can we take all the numbers or all numerical values can be declared as a measure? The answer is no. Okay, for example, I have a mobile phone number. Can I take it as a measure? Answer is no. I have a sales amount. Can I take it as a measure? Yes, because wherever you are performing some, or you can have minimum, or you can perform a maximum, or you can perform average, or you can have a count. Whenever you perform these kind of an aggregate functions on the data, that data is called as a numerical data. I wanted to get what is the sales happened in last month. I wanted to happen what is the average sales across the countries. I wanted to understand what is the sales happened in last month, uh, in the product called rin soaps in say India. So like that you can have a you wanted to perform some or min or max or average operations, not particularly count, but remaining operations have to be performed. So if that is the case, then that will be called as a numerical value, or that numerical value is called as a measure or a fact or a metric. So all the numbers, all the numerical values will not be measures. For example, mobile phone number, PIN code number, room number, all of them. But what are the measures? Sales amount, your salary, your profit, expenditure, and the product price, quantity sold, and a tax which you are paying to the government. All these are examples for what a measures are the numerics. Clear? So what is a measure? If somebody asks you, measure is a numerical value on which you should be able to perform some min, max, average kind of an aggregation. Clear, guys? Now, I wanted to understand that if somebody says we got 1,000 crore profit, but people will not be keeping quiet, they will ask you some more questions. Now, they'll ask you that when is that you got the profit? The first question they'll ask. So they're talking about when it is talking about the time, right? So when is that you got this profit? The customer says that, the CEO says that I got this profit in 2016 and 2017, 2 years profit. So, or you can say that last 3 years, this is the profit I got it. Total 3,000 or 1,000 crores is the profit. The time people wanted to know, and they wanted to understand where did you get this kind of a profit. So the customer wanted to understand, the shareholder of the company wanted to understand, the remaining people in the auditorium, they wanted to understand, because you're announcing all these results in a auditorium, they wanted to understand, so in which location you got this much of a business. So we're talking about location. So are you doing business in India or in Europe or in US or in UK? In which country or which region gave you this much of a profit. We're talking about a region or the location in which you're doing the business, and because of that you got this much of a profit. The next question people are going to be asking you, and how is that you are getting this business? Could be they wanted to understand what kind of a mode you are having. So are you, the sales is happening through offline, or online, or through networking business? So we have a networking business like we have a Tupperware, and we have Evan products, we have a lot of Oriflame products. Lot of business is happening through networking business. There is no branches, or there is no shops will be there. So people are going to be going to the homes, and they will be conducting lot of meetings, and the sales would happen. Is it that kind of a business, or it is through online or offline or through shops? How is that you're going to be selling the products to the company? They wanted to understand the mode of the business. So how is that you're going to be connecting the business? So it could be mode of the business I'm talking about. And which is the product, or which are the products which is giving you more and more profit? For example, I have Apple iPhone, a base, some products in some models in that. Okay, which is the product, or which is the model which is giving you more and more in profit? For example, when talking about in India, we have a Maruti. There is a number one called Alto, and we have a Swift. These are the two products for the Maruti company, which is giving or generating more and more profit. They wanted to understand what are the products and which are the products you are dealing with, and you're getting this much of a business. So that is when you say which, you're talking about which product. The next one we're talking about, who's the user, or who's the customer who's giving this much of a business? Who means I wanted to understand the customers, or sometimes it may not be the customers. So who's the dealer who's getting you this much of a business? So could be a vendor, or could be a dealer. So who's the person who's giving you this much of a business to you? For example, in Hyderabad, we have Varun Motors. He's the number one dealer for Maruti Suzuki cars, and he's getting a lot of revenue in, especially in South India for Maruti company. Like that, you have a special dealers. And we're talking about Hindustan Unilever, and we have Big Bazaar, we have D-Mart, we have more supermarkets. All these companies are giving much more revenue, a lot of a product discount for the Hindustan Unilever products like Lux, Dove, Liril, Rin. All these products from Hindustan Unilever, they wanted to give a lot of revenue, a lot of profits, a lot of sales has been happening through which dealers? When you ask this kind of a question, you will be able to get a lot of data. This data is called as a string data, or these are called as dimensions. Okay, these are called as dimensions. Dimensions means here you will be able to store lot of string data, and here we are storing lot of numerical data. So end of the day, you have only two types of the data in this world. One is called string data, one is called numerical data. All the string data will be partitioned or will be separated as dimensions. All the numerical data will be partitioned or will be separated as factor tables. And you will have all these tables will have primary keys, and all the primary keys will be foreign keys of this table. Clear? So this is what is called dimension modeling. Okay, now I wanted to understand how the in which year you are able to get more sales. When you ask this question, the CEO of the company, they're telling like this: 1,000 crore profit I'm able to get it. Okay, so here they may say that I have in 2015 and 2016, or 2016, I'll say 2017 I got this profit, and 2016 I got 600 crore business profit. You can say something like this. And remaining sales is happened, that is 400 crore business is happened in 2017. So people are not stopped. They'll ask in 2016 and semester 1 what is the business you got it. The next, the hierarchy they wanted to understand is that in semester 1 what is the business, and semester 2, what is the business. Here also, they wanted to understand how the sales is happening in semester number 1 and semester number 2. Okay. Now let me tell you in SEM 1 what is the business. I say that the SEM 1 the business is 200 crores. Now in the semester 2 I'm talking about the business is that remaining 400 crores is the profit. So the same thing would happen in 2017. You may get say 150 crores business here, remaining 250 crores business could be there. In semester 1 they wanted to understand. Okay, they wanted to understand what is the quarter one sales. Okay, the next one is that quarter one and quarter two, and you have quarter three and quarter four. So they wanted to get the data like this. In quarter one, out of 200, I got 120 crores business is happening here. I got 80 crores business is happened there. So that I wanted to tell you. So people wanted to understand slowly what is the business is happened here. Now, after the quarter one, if you go to further, you may be having in quarter one, you have a month and you have a month one, month two, month three. So we're talking about month one. I'm talking about Jan and I'll say Feb and I say March. What is the sales happened in Jan? So Jan, we got 20 crore business, and February, we got 50 crore business and total 70, and remaining say 50 crore businesses happened in this March. Okay, people will not be stopping. So they would ask in the Jan and which week what is the sales happen. So after the Jan, the every month will distributed into week 1, week 2, week 3, week 4, and week 5. So what is the sales happened in week 1? So I'm talking about the week 1 sales, and then we're talking about week 2 sales, then we have a week 3 dot dot dot. Okay, I wanted to ask you. So out of 20 crore, I have some 2 crore businesses happened here. I have 3 crore businesses happened here. Total, I have 5 crore, and another 5 crore businesses happened. So 10 crore, remaining 2 crores is going to be happening. After the week, they'll not be keeping quiet. They wanted to know and which day what is the business. Okay. The next one is that they have to say day one, day two, day three, day four, day five, day six, and day seven. And day one, out of 2 crore, I'll say the business is called say half crore or 10 lakhs or 5 lakhs, something like that. So we are talking about the data, the year level data is this much, the lower level data is we have day level data. So every time you're talking about the data is the sales is happening day level, because whenever you store the data, so whenever the sales is happening, we are storing only the date, right? So day level data, you may be having lot of entries on the given date. So we have to accommodate all this number, accumulate all these numbers. So you have to combine, and you say that on May 10th this is the sales, then May 11th this is the sales, the May 12th this is the sales, and May 10th only you may have 1 million rows will be there. So you have to take all the data for the May 10th or May 11th, and you will be able to get the day level data. Okay, so day level data, you don't think that you have only one row. So you have 1 million data could be sales on that day. You have to accumulate all the data and store it. So you may be taking all the days and 7 days data put into 1 week, 1 week data put into 5 weeks data put into like that months, and months data will become quarters, and all quarters data, 2 quarters data will become a semester, and you should be able to get this kind of a data at the end. So we're talking about the data you will have in the in the fact tables and dimension tables. And one more important fact that you need to understand, the dimension tables will have hierarchies. Okay, hierarchy is not to the fact tables. Clear? Hierarchy for the dimension table, time is a dimension table. So what is the hierarchy? I'm able to explain here. We're talking about year wise. After a year, I have a semester. After the semester, I have a quarter. Then quarter, we're talking about a month. Okay. Then after the month, we're talking about weeks. And after weeks, we're talking about day. What is the lowest level in the hierarchy? Okay. That is what is called granularity of the dimension or the granularity of the data warehouse. Granular means which is the smallest unit. After the day, you can also go, after the day, you can have 9 o'clock time. So which hour? 9 o'clock, 10 o'clock, like, ninth hour, what is the business? 10th hour, what is the business? So after the hour, you can go for the minute. After the minute, you can go for the seconds. After the seconds, you can go for the milliseconds. Although, what is the smallest unit in the dimension? That is what is called granularity of the dimension. So in which level you should be able to, drag and analyze the data? What is the max level? So this is what is called drilling down and drilling up. So rolling up, you're rolling up days to week, or weeks to month, and month to quarter. This is what is called rolling up and rolling down. So if you wanted to create a hierarchical reports, for example, I wanted to understand year wise, semester wise, quarter wise, month wise, week wise, day wise kind of a sales I want to display. So you have to have a hierarchy for the given dimension. That dimension I'm talking about time dimension. Now, you may have more than one hierarchy also. For example, I wanted to visualize the data year wise, then quarter wise, then below that I wanted to visualize the data week wise. So I wanted to have visualization like this. I wanted to have a visualization. This is hierarchy number one. This is hierarchy number two. Okay. So a dimensions can have a different hierarchies also. For example, I take location. Location also you have a hierarchy. What is the location? The hierarchy. Hierarchy could be you have a country, and within that I wanted to have a state, and within that I wanted to have a city, and within that I can have a town also. So what is the lowest level here? The town level. After the town, you can also have colonies, or within that colony you can also have a street. So that is the smallest level. So whatever you wanted to have, for example, when you come to city, and within the city you may have small towns, you can go to that area, and still you should be able to pick up the data. So this is what is called granularity of the in your location hierarchy. So whenever you create a data warehousing, it is very important that you have to create a lot of dimension tables like dim time table, dim location table, dim category or dim mode table, dim product table, dim customers table, dim vendors table, dim dealers table, something like this. And you say that, and we're talking about a profit or the sales amount, fact sales amount, like that. Okay. Then each and every dimensions may have one or more hierarchies, or you may have zero or more hierarchies also. Hierarchy is not mandatory. If you create a hierarchy, that will give you much more drilling up and drilling down supports. Okay. Whenever we're discussing about data warehousing, so how the data warehouse can be designed, you have a dimensional data and you have a numerical data. So dimension means you have this kind of a dimensions where you have more and more string data and more numerical data. You have it. Clear, guys? And these are the points and given by Dr. Kimball. So you have lot many dimension tables are created. So what is a measure? Measures are the numeric values that we wanted to aggregate and slice and dice and analyze the data. Measures has the following properties, how they should be formatted. Formatting means I'm talking about different currency symbols, different decimals points. All of them we need to have a formatting. So how they should be aggregate up? How is that I wanted to find it? Should I find it out the average amount, the total sales amount, minimum, maximum, something like this? And how they are going to be interacting with the specific dimension tables. Okay, so the measure means I'm talking about sales amount. What is the sales amount happened in year 2012, and what is the sales happened in location Hyderabad, and what is the sales for the product Lux. So I'm talking about how each and every measure is interacting with each and every dimension. Okay, so all these things we have to discuss, and measures always answer the questions for how much and how many data in the fact table can be filtered and grouped. Filtering is called as a slicing up the data. So I wanted to understand what is the total sales happened in year 2012. I'm slicing. Slicing means in SQL words applying a where clause, where year of sales equals to 2012. So dicing means I'm talking about in SQL words, it's a grouping of the data. I wanted to get all the sales, happened in India. India is one group, and Europe is one more group, and America is one more group. I wanted to group the data and perform aggregation. That is what is called dicing. Dicing means grouping the data. Clear? So you wanted to group the data and perform aggregations, and after that, you wanted to slice the data. I have India 1 crore, and Africa you have 2 crores, and you have say America you have 3 crores. That is what is called grouping and summarizing the data. But I don't need all the regions. I wanted to take only Africa data, where you are applying is slicing, cutting the data, filtering the data. So the Africa data is two. So you wanted to group it in doing some kind of an aggregation. That is what is called slicing and dicing. Dicing means grouping and performing aggregations. On top of that, slicing means applying a where clause or filtering. So normally in the data warehouse, we're going to be using slicing and dicing of the data. Clear? Now, what is a dimension? Dimension is a string value which always answer the questions like when, where, what, who, which, etc. Examples for the dimension is that you have a customer table, you have a product table, you have a time table, geography table, something like this. Dimension tables, primary keys will be the foreign keys in the fact tables. Dimension contains multiple hierarchies, and hierarchy supports drilling up and drilling down. So slowly we're going to be seeing all these things in practical ways. Okay, so hierarchy speed of the cube aggregation. So this point we'll be discussing about when we create a cube and all. So as of now, you can just ignore this point. Even though hierarchies are optional, the people will recommend that you create a hierarchy. Hierarchy is not mandatory. So you should have in the data warehouse dimension tables and fact tables. And we know that a data warehouse means a time variant, subject oriented, and we know that non-volatile data, all the points we have discussed. And definitely you need to have one more table specially designed for the timetable. So the timetable will not be available in your normal data, OLTP databases. When you see, you have in OLTP, you will have mode of product table, customer table, something like this. But when you take a data warehouse, so when we take it to a data warehouse, we're talking about OLAP, right? So OLAP, you will have two types of the tables. I told you, right? One is called dimension tables, and we're talking about fact tables. Now you have a dim product table, and we have a dim customer table, and we'll have okay, fact sales table. Only one table we have, but we don't have any table. For example, I have a customer called he belonged to Bangalore, he belonged to Hyderabad. So normally OLTP databases will have a column like this, but normally in the data warehouse they don't create a column like this, because always when you want to analyze the data, they don't analyze the data only on the town or the city. For example, the customer will say that after creating a data warehouse, I wanted to analyze country wise, state wise, city wise sales. I wanted to analyze, but when they capturing the data, they don't have the say state, they don't have the country like this. But how can we implement a complete hierarchy? I wanted to have the country, I wanted to have a state, I wanted to have a city. But in the OLTP, you have a customer table, and it is having only the city column. So to in order to have a country-wise sales, if you wanted to get, or if you wanted to get a state-wise sales, or if you wanted to get city-wise sales, that definitely you have to have one more table here that you have to have. The table is called, when I'm talking about a dim location table, which is not at all available in the OLTP. OLTP, normally you take a city as a column in your master tables, but in when you come to data warehousing, so data warehouse is always talking about like this. So time wise they wanted to have some kind of a or data analytics can be performed. And the second important concept is they'll have a location table, geography table is compulsorily they'll have it. So these tables will be missing in your OLTP databases. You have a completely a date column in your factor table. That's it. So on your transactional tables, but when you come down here, you will be compulsorily having a dim time table, or we can say dim date tables. So you will have some more tables compulsorily whenever you create. So remaining tables we're having. Clear? And you have a product key or a product ID. So prod key will be there and product name. Here you may be having customer key will be there as a primary key, and here we will be having a location key will be there as a primary key, because dimension table will have only the primary keys, right? So maximum time. And dim time table, you may have time key will be there, and these are the primary keys. And when you take the fact tables, and all of them, you have a product key, and you have a customer key, and you have a location key, and you have a time key. All these will be your foreign keys. Plus you may have when is the sales amount, and you may have how many products we sold, something like this. This table will be created. So all the primary keys of the dimension tables will be a foreign keys of the fact table. So this is a simple way and easiest way I have explained the concept. And if you don't know what is a foreign key, then please you have to undergo these equal concepts very well. So okay, fact table will have primary keys, plus this is a primary key, and it will have a measures or the facts. What is the measure element here? The measures are that sales amount, okay, and the quantity sold. Remaining things are only the facts. Clear? So this is how the data warehouse for the Amazon database will be created. We were talking about only two tables in earlier situations. When you understand what is a dimension table and fact table, now you get some more tables over there. So the question is that why we have to have dim time table separately. So we'll discuss more and more tomorrow. So tomorrow we'll see how can we export the data from uh, you know uh, OLTP databases. This is OLTP. You have a data, and from here, I wanted to perform ETL operations, and I wanted to export the data to the data warehouse. Okay, you may use SSIS or you may use Informatica, and you will be dumping the data into the destination databases. Okay, so this is how you have to understand how the data warehouse can be created, and how the data warehouse, what are the tables the data warehouse is going to be having. And tomorrow we'll see what are the different schemas in the data warehouse. What is a schema? What is a star schema? What is a snowflake schema? Whether are we using normalization concept here, denormalization concept here? Lot of things still we have to discuss further. And this is how a data warehouse can be created with the help of the this kind of a tables. Am I clear, or do you have any questions?